Okay, chat, so I want to take a look at the improvements I have made. So, this right here is the old design. One of the biggest improvements I've made is to this joint, and this joint here. I'll be showcasing just this joint right now, but all three essentially have the same type of design. And this old joint, we can see here, look at this, like what is this? Like, it literally, did I just break it? Wait, what? I think I just broke. Yo, what? Why is it not going back? Okay. It's not broken, it doesn't really break, it's just not secure. Like, you can just literally do this, and then now the leg is all wonky. Now look at it. Now there's so much bend. And there's gonna be a lot of force on these joints, especially on this one, because all the forces are going this way, and essentially, so you're just gonna have a lot of force, unnecessary torque on the servo itself. So now let's go over the new design, a complete redesign of this. This is very nice looking in my opinion, and this actually improves the thermal, because I've actually added, I don't know if you can tell, but on the inside of here, all the inside here, it's not touching the servo. So what this does is, you know, sometimes I'm very bad explaining things, but it all makes sense in my head. So, and I've added this little slit so that I can just pop this in, and then you can just push this all the way down like so. So on the old design, each one of these go all the way to the servo, all the way down to the servo. So essentially that just creates like little air, it only creates a little channels. There's only 4 little channels where the air can dissipate. But now, if you look in down there, there's nothing touching the metal. So it just gives a bigger surface area for the heat to dissipate, which is a good thing. So we have this piece here, and this piece which goes on top. And it goes on. Okay, this one's a little ugly. I'm still working on my petg printing settings, but this piece goes on here. Mount, screws, whatever, right? And we'll have 2 screws like this. This is the new design. And this is the very greatly improved back piece. We insert 4 heated inserts in here. This will actually strengthen the overall design, and I'll show you how in a second. I also printed this instead of like this. I printed it like this. Printing it like this actually helps a lot with the overall structural part, because the layer lines are like this now. When we put the ball bearing piece on, it's not gonna shear off the layer lines. It's not in line. The ball bearing is not in line with the layer line, so it's not gonna shear off as easily. So it's gonna be a lot stronger. And so we have this piece here, like so, and this piece. We still need to sand a little bit off of this piece here. We can do that with a little sanding paper. This needs to be quite smooth. The smoother this is, the better. You know, when I'm doing scarf inseams, it's just always under extrudes. I don't know how to fix it. And I don't know, maybe my printer settings are just not crappy, but okay, this is awesome. So this piece goes here, like so. This cap goes on here, and this piece will mount here. But before you mount this, for an actual build, obviously, once you put this on, you want to screw it in, because once you put it on, you won't be able to screw it in, because this will be in the way. But, so this piece now goes right on here, which takes a lot of force to get into, because I actually designed it that way, so that it's stronger. I can't even get this off. Okay. So this piece will go on here. This is very, very difficult to get my hand off. I think it's all around. All right, this is nice. This looks very nice. And you can see just how parallel they are. and you can see the movement. Like you can't feel it, but it's very, very smooth, and it's very, very, very hard to get off. And let's see. You can see if I apply force here, it essentially doesn't do anything to it. It doesn't move at all, which is because of the larger surface area. Switching from 4 to 7, and it's a bigger ball bearing in general. And what I'm talking about with these heated inserts is doing it this way. We'll have screws on top like this. The screws will run all the way through out the back. So this will make it very, very, very strong. Okay, I don't know what length screws I need. I probably should have thought about that, to be honest, but it's okay. We can figure it out, don't worry. Let's see. Let's drill most of these holes. They're definitely too small. Okay, so for the actual design, for the actual build, I'm probably gonna drill these holes a little bit smaller so it screws in a little tighter. This is too long, I think. I think we're gonna go for these 20 millimeters. Or I can just go on the CAD and actually check, but why would we do that when we could just test different screws and hopefully it works, right? So this is very secure, and we can see this actually fits pretty nice. So we need to just unscrew this a little bit. Okay, so we need to somehow design it in a way so that we're actually using 20 millimeter screws. Now we can see that there's a lot of friction on here, I guess it's not really a bad thing because these servos have so much torque. Well, there's not a lot of friction, but we can minimize this by just unscrewing a little bit. Like this, and then now it's very smooth. Yeah, it's very, very smooth. And this will never come off, and this should slot on here. I think what I'm going to do is raise this piece by 1 more millimeter. Raising this piece by 1 more millimeter will pull the screw like this way by 1 millimeter, so we can use a 20 because this is pretty flush, but it could be more flush with the surface. Now this piece goes on just like so. Yeah, this is very, very strong. If we put on 4 of these screws, this will literally be unbreakable. I really, really highly doubt this will ever become an issue. If it is, then I don't know. This is very, very sturdy. So we'll screw, wait a second, this might be too big. Is that what I used earlier? I think it is. So let's actually unscrew this and drill out the rest of the holes so that it fits. What? How did it run out of battery? I literally just charged it. I'm so confused. Okay, switch drills. Yeah, genuinely no idea how that ran out of battery. I literally charged it. That is so weird. Maybe the charger's broken or something, I don't know. You definitely want to be careful. Not hurt yourself while doing this. It'll be not very nice. So this piece goes here, this goes here, this goes here, and need 1 more. We're gonna end up using a lot of screws. Yeah, this hex plot is gonna take a lot of screws, but I kind of designed everything to be overkill, especially like everything basically. Like this will literally never. I really doubt we need 4 screws here. I think just 1 screw will be good enough, but let's just start. The servos are already overkill, so this is very, very, very sturdy. And we can loosen it. We can loosen it by hand. I'm thinking we might, because this is not on very tight. I think we can make this a little tighter. Some we need to loosen, some we need to tighten. I think we can actually raise it by 1 more millimeter. Maybe not. Maybe we do need some pressure, like some more pressure like this. It's not bad, I mean. Okay, this is pretty nice. So yeah, we can, I'm just afraid the vibe, actually no, it won't be a problem because on the actual design, the final design, when I do everything, I'm not gonna drill the holes as big so they actually dig into the plastic so the vibrations won't be able to, the vibrations won't be a problem. So you can just hand tighten these by hand if we want more friction or if we want less friction or whatever. But this is actually pretty neat. I just need to raise this by 1 more millimeter, which is a good thing about printing it and actually testing it so we can actually figure everything out. Yeah, this is